Okay, so in this illustration, I am going to be looking at number 13 in your textbook. And it talks about the mean income per person in the US is 40,000. They give you its normal curve, samples 10. They give you the sample mean. Notice again, it's the sample standard deviation. So this again is going to be, in this case, it's going to be a sigma unknown scenario. And so the conclusion wants to be, we want, notice it says have incomes more than the national average. So if we go ahead and formulate our hypothesis statement, I would say that the alternate, you want that to be greater than 40,000, and therefore the null is less than or equal to 40,000. So we know that this is going to be an upper tail test. The alpha level is going to be 0.05. I'm going to put the sample up here. The sample size in this problem looks like it's 10, so we know it's going to be degrees of freedom with 0.05. And so because this is a one-tail test, again, 1.833 from our table is our critical value using the degrees of freedom and alpha. Again, you're going to follow the one-tail test over here, so I got that right there. And then to actually do the test stat, it's simply just plugging it into your formula. So it looks like that the average, let's go back up and find the average, that the average in the problem was 50,000. So 50,000 was the sample mean minus 40,000 all over. It looks like the standard deviation in this case is 10,000 divided by the square root of 10. Now, if you plug that in, you're going to get a test stat that's right about 3.16. You compare that up here, and definitely that is in a rejection area. So our conclusion is going to be we're going to reject the null and accept the alternate as true. And that's basically how you would do your conclusion. Now, if you wanted to get the p-value in this one, again, try looking at 3.16 in your table. You go to the same row of 9. It looks like 3.16 is going to fall between this 2.821 and 3.25. So notice this is going to give you between these two values is your p-value, somewhere between there. You'd say it's between 0.005 and 0.01 as your range. And that's definitely less than or equal to alpha. That's a very, very small p-value. So that's definitely going to give you a rejection area. I'm sorry, a conclusion of reject the null.